Hello everyone, you're welcome to this channel. In this video, we want to evaluate the integral from 0 to a of y to the power 4 multiplying the square root of a squared minus y squared dy. So if this is your first time on our channel, don't forget to like, subscribe and then comment as well. When you look at the question very well, it looks quite weird. So to make it quite simpler, what we are going to do is that we are going to compare the question here with the beta distribution, which by definition is giving us the integral from 0 to 1 of x to the power m minus 1 multiplying 1 minus x to the power n minus 1 dx. So if we are able to convert this integral to be like something of this form, then we can solve it in a simple way. Now let's start. So we can write this as the integral from 0 to a of y exponent 4 multiplying a squared minus y squared exponent half dy. And then looking at the beta distribution, we have 1 minus x. So how do we get 1 in this bracket over here? So to do that, we can factorize a squared out so that we can get the one that we want over there. So in this case, we are going to have the integral from 0 to a of y to the power 4 multiplying, and then we are bringing a squared out. We are going to have a squared, and don't forget the exponent here is affecting what is inside the bracket, so we need to also attach an exponent to it, leaving 1 minus y squared over a squared, all exponents 1 over 2, then another bracket dy. And now from here 2 can take care of 2, so you are going to be left with the integral from 0 to a of y to the power 4 multiplying, here we are going to be left with just a into 1 minus y squared all over a squared exponent half dy. And then now since we are differentiating with respect to y, that means a becomes a constant, so let's move a before the integral sign. So when we do that, we are going to have a multiplying the integral from 0 to a of y to the power 4. Then here we are going to be left with 1 minus y squared all over a squared to the power half dy. So now we have the one that we want. So to be able to get this form, we are going to let u to be equal to y squared over a squared. So y squared over a squared. Since we have let u to be equal to y squared over a squared, it means that we are going to change everything over here into u. So now we have here in u. So let's try and then change y to the power 4 also to u. And now we know that u is equal to y squared over a squared. Now from here, when you want to make y squared the subject, you are going to have y squared is equal to u times a squared. Now from here, we have y to the power 4. So to be able to get y to the power 4, that means we need to multiply the exponent by 2. So we are going to do that on both sides. Doing that, you are going to have y to the power 4 is equal to u multiplying a squared all exponent 2. Now we'll be able to change this one. Now we need to change the y also into du. And then from here, when we make y squared the subject, we are going to have y squared is equal to u times a squared. Now y will be equal to the square root of u times a squared. And now from here, dy du will be equal to a squared over 2 times the square root of a squared u. So when we make dy the subject, we are going to have dy to be equal to a squared over 2 times the square root of a squared u du. Now that we have been able to change dy into this form, and then y squared over a squared also into u, and then we have also changed y exponent 4 also into this form, what we are left is to change the limits. So how do we change the limits then? Now when y is equal to a, we are going to have u to be equal to a squared over a squared, which is going to give us 1. And then when y is equal to 0, we are going to have u to be equal to 0 over a squared, which is going to give us 0. So we are going to fix whatever we have had for all the expressions into this integration to see if we can still match the beta distribution. Now let's do that. So let me clean here. Now from here we are going to have a multiplying the integral from, now when y was 0 we had u to be 0, and then when y was a we had u to be 1. Now we are having y to the power 4, which we expressed as what is over here. So we are going to have u multiplying a squared all exponent 2 into bracket 1 minus, and then u squared over a squared, we let u to be equal to that, so we are going to have u here all exponent half, and then the y, we have also expressed the y as a squared over 2 times the square root of a squared times u du. And now from here we can write this as a multiplying the integral from 0 to 1. We can expand this bracket over here, getting u squared times a to the power 4 multiplying 1 minus u exponent half a squared over, and then from here we can write this as 2 times a squared multiplying u exponent half du. Now let me clean this side. Now from here, since we are differentiating with respect to u, it means that 2 is a constant and a is also a constant. So we can bring that one out. So doing that, we are going to have a times a exponent 4, and then these two out, so we are going to have times 1 over 2 multiplying the integral from 0 to 1. Here you'll be left with just u squared multiplying 1 minus u exponent half, and then here the 2 is gone, so we are going to be left with a squared over, now here we can also write this as a exponent 2 times half times u exponent half all du. So let me clean this one also. And from here, using the law of indices, we are going to have a exponent 5 times 1 over 2 multiplying the integral from 0 to 1 of u squared times 1 minus u all exponent half. And over here we are going to have a squared over, so the 2 here will cancel out the 2, so we're going to have a squared over a times u exponent 1 over 2 du. Now from here, a can cancel out this, so we'll be left with 1 at the top. And then since we are differentiating with respect to u, that means a is constant, so we can bring a out, getting a exponent 6 over 2 times the integral from 0 to 1 of u squared multiplying 1 minus u all exponent half. And then here we are going to be left with 1 over u to the power half du. And then from here, we are going to have a exponent 6 over 2 multiply the integral from 0 to 1 of u squared multiply 1 minus u exponent half. And then here we can write this as u exponent negative 1 over 2 du. Now using the law of indices, we can combine this and this. So doing that, we are going to have a to the power 6 over 2 multiply the integral from 0 to 1 of u exponent 2 minus 1 over 2 times 1 minus u exponent half du. And now we are going to have a exponent 6 all over 2 multiplying the integral from 0 to 1 of u exponent 2 minus half gives 3 on 2 multiplying 1 minus u exponent half du. Now from here, when we compare this with the beta distribution over here, we can realize that we are having the integral from 0 to 1, and then we have s to the power and exponent, where we have also had u to the power and exponent multiplying 1 minus x to the power and exponent. We also had 1 minus u multiplying an exponent. du, and then you also have the x over here. Now let me clean this side. So having obtained something similar to the beta distribution, it follows that we are going to use the beta of mn is equal to tau of m times the tau of n all over the tau of m plus n. And then when we compare this with the beta distribution over here, we can realize that m minus 1, which is over here, is the exponent here. So it's equal to 3 on 2, which we are going to have m to be equal to 3 over 2 plus 1. So m will be equal to 5 on 2. And then from here, n minus 1 is also equal to half. N minus 1 is also equal to half. So you are going to have n to be equal to half plus 1, which is equal to 3 on 2. So in this case, we are going to have the beta of 5 on 2, 3 on 2 is equal to tau of m, and m is 5 on 2. So you are going to have 5 on 2 tau of n, and n is 3 on 2, all over the tau of 5 on 2 plus 3 on 2. So from here we are going to have tau of 5 on 2 times the tau of 3 on 2 all over tau of 5 on 2 plus 3 on 2 is going to give us 8 on 2. And 8 on 2 is 4, so tau of 4. Now when we have a tau of a fraction, we can simply express that as, say, tau of x is equal to x minus 1 multiplying the tau of x minus 1. So in the case of a fraction, this is what you are going to use. So let's consider tau of 5 on 2. So the tau of 5 on 2. So this is equal to, now x minus 1. So we are going to subtract 1 from tau on 2. And when we do that, we are going to have 3 on 2 times the tau of, and then x minus 1, which is going to give us 3 on 2. And then again, we also have a fraction here. So we need to apply the same thing to be able to reduce it. So when we do that, we are going to have, now let me clean this side. So from here, we are going to reduce it using this same property. So we are going to have 3 over 2 times, so 3 on 2 minus 1, we are going to have half. So times half times, and then here we are going to be left with half. So half. Now here we are going to have 3 times 1 gives 3, and then 2 times 2 is 4. And by definition, tau of half gives the square root of pi. So this is for the tau of 5 on 2. Now let's do for the tau of 3 on 2, which is this one. We are going to have the tau of 3 on 2 is equal to, so using that same property, when we subtract 1 from 3 on 2, we are going to get half times the tau of 1 on 2, which we are going to have tau of 1 on 2 by definition gives the square root of pi. We are going to have half times the square root of pi. And the tau of 4 is simply 3 factorial, which we are going to have 3 times 2 times 1, which is going to give us 6. So here we are going to have now tau of 5 on 2, we had 3 over 4 times the square root of pi. So we're going to have 3 over 4 times the square root of pi times, and then tau of 3 on 2, we had 1 over 2 times the square root of pi. 1 over 2 times the square root of pi all over, and then tau of 4, we had 6. So this will be equal to, so let me clean this portion. So this will be equal to, so here when we multiply the two terms, you are going to have 3 over 8 pi all over 6, which is equal to 3 over 8 pi times, then we can reciprocate the denominator to get 1 over 6. And here 3 cancels itself once and then goes into 6 twice. So I'm going to have 2 times 8 is 16. So I'm going to have 1 over 16 pi. But don't forget what we did was in effect of this side. So we left a exponent 6 over 2. So we are going to multiply a exponent 6 over 2 by this one. So doing that, we are going to have a exponent 6 all over 2 times 1 over 16 pi, which we are going to have a exponent 6 all over 32 pi. Now we have a exponent 6 all over 2 times beta of 5 on 2, 3 on 2, which in effect is going to give us a to the power 6 over 32 times pi. So this is the answer to this question. Thank you for watching. If this is your first time on our channel, don't forget to like, subscribe, and then comment as well.